A grand hello to my fellow 28mm wargaming dudes and dudettes. This month we have a review of our entire Fallout Shelter project from start to feature complete. It spans from October of last year to November of this year. Thanks for helping us get to this major milestone. We hope you find some value from the lengthy review. We'd be obliged if you'd throw us a like and subscribe.
Long ago in the 40K timeline, a corporate entity tried to save humanity by building many massive underground shelters. This company was of course Vault-Tec. We all know how that turned out, but what is not well known is what happened to many of those vaults in the time since then. Some were destroyed, some lived a useful lifetime and then were abandoned. However, some of them were never heard from after the nuclear war that Earth endured 40,000 years ago in the 40K timeline. In the 41st millennia, Terra is an almost entirely explored and exploited planet. However, there are still a few surprises in store for the Adeptus Terra. We're going to build one of those vaults that went quiet and was forgotten about for thousands upon thousands of years and has since been rediscovered in the time of 40K. Our heroes, Captain Knable and Lieutenant Melina, two honor-bound Cadian soldiers, while serving a tour of duty on Terra, were assigned to investigate a rather odd power signature that was detected after a major seismic event. Imagine their surprise when they uncover a fully rendered underground city. Join us on this journey of construction, experimentation, animation, and frustration as we build and rationalize how a Vault-Tec vault showed up on the Emperor's doorstep in the 41st millennium. Together we can figure out how this piece of terrain can be used in Kill Team, Necromunda, or Narrative 40K campaigns. While not everyone may enjoy the lore mashup, suspend disbelief for a while and have some fun figuring out how these two great franchises can coexist in our current 21st century. I've played a lot of Fallout Shelter, the cartoony version of the Fallout franchise. Given that, the vision that developed in my mind was how to build a Vault-Tec vault that actually looked like those of the Fallout Shelter game. It starts with a blank piece of MDF, upon which we measure out and draw how the vault will take shape. Vaults are underground, so I landed on an idea of a slice of earth lifted out of the surrounding area so we can see above and below ground. Once the rough outline of the mountain slice was idealized in Sharpie, I drew out the width of each room, the elevator, and left enough foam on the outside to ensure I can carve some interesting underground vignettes later on. With that done, I cut a wooden frame of 1" by 3" planks and mounted them onto the base. Then I cut some XPS foam 2 inches thick, and those became my piece walls. I needed a way of building a drawer structure. Ironically, I had to Google how to build drawers. Once I realized I was building a dresser, it was easy to find drawer sliders and plans on doing just that. That involved some conventional carpentry while making sure my drawer fronts were open to see like the Fallout Shelter game. With the design solidified, I started to build the actual drawers. They had to be high enough to support 40K figures, and they had to be able to be pulled out so you can play in the drawers themselves. This took a bit to measure and fiddle with, but in the end we have 8 rooms that can be pulled out to move your gang around. Using cardboard to build the rooms allowed me to make precise cuts without having to have a full-fledged wood shop. After the drawer shape was built, I lined all the edges with a wee bit of card, knowing that I could cover the edges in low viscosity superglue and then sand them so the action on the drawers was nice and smooth. In some of these pics, you will see a small sheet of foam core being used to ensure the drawers were the same distance apart and they would not bind on each other when the rooms were pulled out. To provide additional support on the drawer sliders, I lined the interior top perimeter of each drawer with popsicle sticks. This allowed me to use screws to connect the drawers to their sliders in a much more durable fashion. Whenever I build, I constantly remind myself that these things are meant to be played with and need to stand up to that. At this stage, the screws are too long and will be cut down later on in the construction phase. To match the image of the Fallout Shelter game, the elevator is directly between each side of the drawers. At the bottom, I will build an infinity mirror that makes it appear that the elevator shaft continues further down into the mountain. Above that section will be the elevator car itself and will be animated so that it is always moving up or down. As you can see in the early pics of the elevator shaft, there are 2 vertical channels cut through the shaft. This will be how the car is lifted and lowered. By extending some card through the channels will allow me to mount a cable system to the elevator. The very top of the elevator shaft will be where the motor and any other electric devices will sit. I haven't decided yet if this will be hidden or not. The last thing I want to point out in this first video is where all the electronics will go. The backplate of XPS foam on the mountain is removable and will give me access to all the electronics that this piece will require. The cavity between the rooms will be used for most of the electronic installations. I built a vertical slider that can be pulled out for access. This MDF plate will be where the Arduino gets mounted along with the rest of the circuitry. Add to that, there's about 15 centimeters behind each drawer that can be used for wiring and any other engineering work that needs to be hidden. The very iconic vault door will be on top of the slice of earth. It will be modeled in such a fashion that it looks like a recent earthquake has uncovered this long-lost relic. The top of the slice of earth will also include some 40K elements that will allow us to bridge the two franchises together. After rough cutting the elevator shaft out of foam core, we build the wall inserts. There are 3, the back, left, and right. They are built and painted prior to installation so that we can effectively detail them without having to work within the confines of the shaft itself. There are 2 channels cut in the back of the foam core shaft to receive the tabs from the elevator car. These will be mounting points for our gearing assembly. After the side and back walls are cut, we add some card doors. Those get mounted to the shaft panels, one on each side at every floor. Here we are adding some wire conduit bits that line the shaft. These are simply aesthetic and do not carry any current. You'll notice the girder beams that have been cut with a single hole punch in preparation for adding them to the shaft walls later on. We will now add the girder panels to all sides of the shaft. These are layered on to give a more pronounced 3D look. By using low viscosity superglue, we can sand the cardboard to a smooth surface without it fraying. At this point, we want to test fit our panels. We want to make sure that there are no gaps showing. We are now drilling the holes for the shaft lights. Cardboard is a pain to cut cleanly, so after the hole is punched, we soak it in runny crazy glue and we will sand it smooth later on. With the panels built, we can throw on a coat of black primer. No great secrets in this step. We simply want to ensure there is good coverage. We need to make sure this dries thoroughly before moving on to the next steps. Using a pastel blue color, we dry brush all the panels. Add some rust effects and then tape off the doors so we can color them more efficiently. We will add some rust effects to the door and the frame later on. Removing the painter's tape, we get a good view of the finished shaft wall panels. Given that the Fallout world is based on 1950s technology, most of the colors in the vault will be pastel colors with some harsher rust effects on top. For these sections, we use tropical blue, daffodil yellow, and gray. All the colors are dry brushed on to keep anything from looking brand new. With most of the painting on the panels done, we test fit them again into the shaft. At this point, we're looking for a proper fit with no unpainted surfaces showing. It is starting to look like an elevator shaft now. Testing lights is of paramount importance in layered building. At some point we will accidentally cut a wire and have to fix it. Constant testing ensures we find out quickly if and when that happens. Next up is to build the elevator car itself. It is all cardstock. All the car walls are cut before assembly. We use super low viscosity super glue to put the car together. The 1, 2, 3 blocks are used to ensure the car goes together square. The top and the bottom of the car is beveled a bit so that it does not get caught up on anything in the elevator shaft. The last step in building the car is to ensure everything is square. We add more low viscosity crazy glue to ensure everything is bound tightly. When the glue dries, we can sand the card without it fraying and get a nice finished edge to everything. With the back wall installed in the shaft, we carve out the mounting channels with a Dremel and then use a sanding bit to ensure the grooves are nice and smooth. The sanded edges combined with the beveled top and bottom, the car will not bind on anything in the shaft. We can now glue the shaft panels into place. PVA glue is used so that we have time to ensure everything is square before we lock them down with clips to dry. Crazy glue sets way too quickly for this particular application. With the panels installed, we can now test fit the elevator car. At this point, we want the car to slide up and down the shaft in a very smooth fashion. Graphite lubricant is used in the channels on the back wall to promote this. Now that we are satisfied the car slides smoothly through the shaft, the mounting pins, which are bamboo skewers, are added through the tabs on the back of the elevator car. This configuration locks the car into the shaft itself. Many more test slides are done. I test slid the car at least 100 times. The pulley system will be mounted to the car's tab assembly by way of another bamboo cotter pin to be added later. Next, we take the elevator shaft and bore a hole through the back wall. The winch motor will be mounted at the top of the inner shaft with the winch drum extending through the hole in the back wall. Here we see the winch motor assembly being tested. It is a 5 volt 30 RPM DC motor attached to a sewing spool. The video is sped up a bit, so it looks a little bit faster than it really is. All the electric and mechanical devices need to be take apartable, so it was built on a removable platform and then installed at the top of the elevator shaft. With the winch and motor installed, we test the elevator car action. This is prior to the limit switches being installed. The limit switches are now installed and are tested by ensuring they are in the correct location. Each limit switch needs a positive and negative lead routed to the Arduino. These are the wires that will detect when the elevator car triggers the limit switch. Once the wiring is soldered, we will test the function of the switch with our multimeter. When the switch is activated, the circuit closes and the Arduino will detect it and stop the winch. Wait a bit and then rotate it in the opposite direction. With the wiring done and the Arduino program written, we test the fully automated action of the elevator car. Within these shots, you can see the elevator car sled pressing the limit switch and then reversing the motor. Here is the elevator assembly installed into the vault. There is an infinity mirror at the bottom of the shaft to give the illusion that the elevator descends further into the mountain. The mountain cube has a plate on the back that can be removed to provide access to all the electronics within the mountain. The toughest part of building this was making sure the drawers can be opened and closed for play access without the wires getting all tangled. This was accomplished by creating the center channel between the columns of rooms. All wiring will be directed into this space. Immediately behind the elevator in the front is a set of hallways that allow access between the columns of rooms. Given that these halls will not have convenient access, I needed to build them in such a way that they did not inhibit the drawers opening and closing. The hallway boxes were built, and to ensure I could paint the interiors, the walls, ceiling, and floor of each hallway tunnel were built outside the main corridor and will be installed once painting is done. I cannot stress enough the value of using sub-assemblies to ensure you can detail the pieces properly. In the lore of the model, there was only enough air in the hermetically sealed vault to cause roughly 100 years of wear, hence why the vault is still in good shape after 40,000 years of being buried. With the hallway wall inserts painted and clear coated, the next step is to test fit them into their final position. The ceiling lights are tested prior to permanent installation. The stack of hallways were meticulously measured to ensure they rise to the proper level and match up with the holes cut in the drawer rooms. They were mounted with neodymium magnets in case I need to remove them in the future. Other than that, these will likely never move again. It never made sense to me in the Fallout Shelter game that you had to use the elevator to move between rooms, so the answer for me was the corridor behind the elevator. The hallway corridors are now ready to have their wall, ceiling, and floor inserts glued into place and held with the clips while drying. PVA glue is used so I can adjust their positions prior to the glue setting. Once dry, a wee strip of card is added to the ends to hide the double wall of the corridor. This was then primed flat black and they are ready for installation. Here you can see the corridors installed and wired up. They exactly line up with the access ports for each room. The wiring drops to the floor where it is secured with enough slack for the electronics tray to move freely. The primary lighting was built with a bunch of $3 LED strings from the dollar store. There are 8 light strings in total. I measured out 20 holes and used hot glue to install the lights themselves. Each room's lights are installed on the bottom of the room above it. When the lights are glued in place, I simply coil the excess wire up and insert it into the channel cut into the ceiling. There is only a 5mm gap between each room drawer. The LEDs from the dollar store were ideal as they were tiny. The hallway lights are wired with a 220 ohm resistor and then attached to a 9-volt bus bar on the electronics tray. The leads for each floor are directed into the channel between the column of rooms and do not interfere with the drawers opening and closing. With all the lights installed, I then used masking tape with a wee hole punched into the center to give the lights a bit of a pot light look. Adding masking tape on top of the lighting channels ensures that they will not show once they are painted. Each light was covered with a hole punch of painter's tape, and the entire assembly was painted flat black to avoid drawing attention to the ceiling. These last few images show the lighting finished and powered up. It took me about a month to build these items, a very tedious process with not much visual appeal, but the wiring infrastructure is very important and will now be used for every room that gets built. There are quite a few Fallout vault door builds on YouTube. What most of them don't do, however, is the retraction of the door. That is to say, the door slides back then out of the way. I was pretty determined to animate that action in this build. There are two primary motions with the door, the dolly moving back and forth, and the door plunger moving back and forth. Here you can see the dolly being installed into its guide runners. Most of the electronics are contained on the dolly itself. This includes the limit switches, voltage booster, and the H-bridge that controls the motor's polarity. The dolly electronics hook up by way of connectors to the base of the gate room. This allows me to take things apart to perform maintenance, diagnose problems, and will allow me to paint the various assemblies separately. This wiring harness was too frail, so it ended up getting replaced later on. The dolly worked well with the rack and pinion actuator. However, I discovered early on that it needed extra weight on top of the gear that runs along the track. I used a wee cube of bolts to provide that weight directly onto the gear. It worked quite well and virtually eliminated any gear slippage. I needed to ensure the user saw the big honking gear that the vault door spins on. To this end, I built a circular frame for the vault door and added a rack gear at the bottom. The teeth from the gear on the door ensures that this door spins gracefully when the dolly retracts to its fully open position. Building this assembly was quite tedious and time consuming, as the spacing on the cogs was very important and I had never built this type of assembly before. I ended up building 3 versions before I got one that I was satisfied with. I have newfound respect for mechanical engineers and the precision they work with when building systems. The vault door itself still needs a lot more detail, but at this stage I am simply ensuring the mechanisms all work okay. The center spindle is where all the work happens with the door. It's a 3-inch bolt mounted to a bearing by way of epoxy glue. This allowed the door to rotate when it catches on the cogs on the floor. Additionally, the bolt was hollowed out and a bamboo skewer was inserted to lengthen the axle. Several mounting holes were drilled into the bamboo to support the push rods and connection assemblies. They are all secured via cotter pins. By using several bearings and push rods, the door, or plunger, is moved forward and back by way of the blue servo motor. Once the door motors and mechanisms were built and known to be working, I built a couple custom cowlings for the dolly that hides most of the internal gubbins. Door screen was used so that the viewer can see all the mechanics running, but will allow me to obfuscate anything that does not look to scale. The cowlings are made from cardstock 5mm stir sticks, door screen, and toothpicks for mounting lock pins. Once all painted up, the motors will still be seen, but in a much more subtle fashion. The platform for the door itself is the first piece of GW bits used in the model. Using railings and platforms from the Zone Mortalis sets created a respectable looking deck and railing structure. This assembly needs to allow the door to move freely, but still allow models to move about the gate room when the door is completely opened. More bits and electronics will be added later to create the door console, elevator, and other gate room accoutrements. Given how important and iconic the vault door is in Fallout lore, the outer facade of the gate door needed to really look good. Using multiple layers of cardstock in a bas-relief fashion allowed me to create a decent look for the outside of the vault. As mentioned, the door itself will have more detail added later for the pièce de résistance. The lore of the piece dictates that this vault has been buried for 40,000 years. Therefore, there will be no functioning electronics on the outside of the door. Eventually, the door assembly will be powered via the 9-volt battery array installed in the mountain. For testing and sub-assembly creation, the Arduino is powered from my PC, and the motors are powered via power supply set to 5 volts. Here we see those connections being set up just prior to power up. With everything installed, we can now go through the door's power up and initial cycle. It takes a few seconds on power up for the door to realize where it is at and adjust accordingly. Here we can see the door open-close cycle from the front. Notice how the door plunger retracts before it starts to move to the open position. All in all, it's really starting to look good. Our last view for today is that of the door cycling from inside the gate room. Notice how the door moves over the railings and platforms smoothly without impeding the door's movement. Eventually, the door will have sound, lights, and some animated computer screens as consoles. But that is a topic for another day. Our gate room base currently has the assemblies for the door action, the Arduino, the speaker, MP3 player, and all other wiring necessary for the gate room itself. Additionally, the floor has been covered with screen for an industrial look, and the platform in front of the gate is made from some GW Sector Mortalis bits. This entire base will be inserted into the top of the mountain, which is being built separately. To ensure we can access everything for painting and to perform any maintenance on the electronics, all these pieces need to be take-apartable. The gate room is no exception. Therefore, all the walls are pinned into place with toothpicks. As we install the right wall, you can see the electronics already installed as well as the wall girders. All other details will be built and painted separately and then installed. The flashing lights on the wall will be plugged into a flasher circuit and then controlled by the Arduino. The front wall is set up so you can move your minis around the gate room. This will then be covered by some rock work to give the illusion of looking into the cutaway of a mountain. By itself, it is a pretty frail wall. To help with this, I installed a cross member at the top and lined the opening with coffee sticks. This really firmed up the construction. When you pin it to the surrounding walls, the frailty is gone. Lastly, I added a wire channel at the bottom that will hide future wiring. The left wall is very similar to the right wall and has some pre-wired electronics, I-beam girders, and vents. The white plates on the girders are cast rivet plates that I purposely built for this model. They hide the I-beam joints very nicely. As with the other walls, once it is in place, pins are used to hold it tight. More greebles, gubbins, and details will be added as sub-assemblies later on. These will include HVAC equipment, wiring and piping conduits, and computer consoles. The gate wall was the most detailed to build. The outside needed to be artistic enough to do the iconic symbol justice while still fitting into place within the walls. This was accomplished by having lock joints that fit snug into place before lashing the wall with pins to the other walls for support. With all the walls now installed, the structure is quite rigid and strong and can endure some manhandling while building working with the rest of the model. To support the lore behind the piece, there are no functioning electronics on the outside of the gate, as they deteriorated away thousands of years before. The inside, being hermetically sealed, only experienced about 100 years of decay before all the air and moisture dried up. Here we can see a quick overview of the gate room with all its walls installed. The ceiling contains a string of LED lights, more I-beam girders, and the framework of a gantry crane that will be detailed later. It all fits neatly into the frame created by the four walls. To get to the vault from the gate room, denizens will take an elevator down to the first level of the vault itself. This wee bit will have some lights and gubbins added later. With everything installed, we can power up the door and see how it looks with the lights on. The action of the door includes the moving of the dolly back and forth, as well as the door plunger pushing the door into place. From this angle, you can see how the door moves over the railings and floor areas smoothly. Just enough of the motors and gears now show to be interesting. Most of the internals will be hidden from view. Taking the roof off allows us to see into the gate room while the door is activating. You can see how the plunger retracts and the dolly moves out of the way for access to the door opening itself. There are still a ton of details to be added, including greebles, gubbins, odds and sods, and other minor electronics. These will include computer consoles and items that have decayed. The gate room is now construction complete and ready for painting and detailing. The vault room that we built previously can now be installed onto the mountaintop. We need to ensure the power conduits line up. I built a sliding track that ensures the conduits line up and the vault room stays in place. The power is supplied from the mountain's main power bus leading from the control switches. Once the vault room is slid into place, we fish out the bobbin that holds the power leads coming from the main power bus. It is a little bit fiddly, but I don't expect to be taking this apart too often. The safety stripe bit is merely to ensure the power leads don't drop into the mountain, making it difficult to fish out. The bit is then hung on a hook to stow it. The vault room now has power fed from the main switch array. With the vault room installed, I can now put on a rough mountain top that I blocked out from 2-inch XPS foam. There are some grooves in the ceiling to ensure it fits snugly on top of the vault room. Once fit, it is ready for carving. The mountain top will be carved as a desert mesa top, and the rock detritus during an earthquake fell away to expose the gate entrance. With the top installed, we power up the mountain and you can see the rear access for the electronics. You can see the main switch array on the bottom left, the battery array on the bottom right. I suspect this piece will need a lot more batteries as the motors and the displays suck up a lot of power. The vault door currently opens and closes every 30 seconds and will ultimately be activated with a wireless controller. You start to see how the mountain will enclose the vault room. Spinning the mountain around, you can see the installed gate room and the drawers that will be the vault rooms themselves. Here we see the vault door action from inside the gate room. You get a good shot of the warning lights and there will be sound, but as of right now, adding an MP3 player is proving difficult and I'm waiting for some new parts. The gate room has enough space to move your models around, and the drawer rooms will easily open and close for gameplay. I expect movement from floor to floor via the elevator will simply be considered difficult terrain. Now that the mountaintop is blocked out with XPS foam, we can start to carve it into a more realistic looking shape. The hot wire foam cutter is a modeler's dream for this type of work. You can see where I used bamboo skewers as holding pins that needed to be removed prior to carving the foam. The hot wire cutter does not cut bamboo very well. Ultimately, the vault door will be deep set into a cave-like recess. The sides of the mountain, sliced away, will have a variety of vignettes carved into it. These will include tunneling rad roaches, buried treasure, and other interesting scenes. This is the rough cut of the mountaintop shape. For the final look, the foam will be carved into detail that represents a desert-like mesa rock face. When the rough cut is finished, we end up with a perfectly fitting cap that will be removable for maintenance and painting. Once the foam rough cutting is done and the mountaintop cap is in place, we get a full view of the mountain slice. The edges of the mountain will be finished with some wood strips that will provide a finished look while providing stability and structure to hide any rough edges. Things are really coming together now, and our next step will be the first room, the overseer's office. That, however, is a video for another day. The overseer's office is the first room newcomers will see when they enter our subterranean vault. As you can see here, there are 9 major components that went into building the overseer's office. The outer shell is what gets mounted to the drawer sliders in the mountain. The Arduino that will control the video monitor is mounted on the back of the outer shell and can be accessed through the back of the mountain. Additionally, there is a 5-volt bus bar for powering lights. The inner shell allows wiring to be hidden and is where most of the construction occurs. This will ultimately be installed inside the outer shell. All of the wiring will be directed to the back of the inner shell through the outer shell and connect to the Arduino. A server room was built with UV lighting and some fiber optic lights. This box is wired with the UV lights, server room door lights already installed and gets mounted at the back of the inner shell. There is also an elevator shaft that runs from the gate room to the overseer's office level and to the first floor of this room. This elevator shaft contains the elevator door lights and wiring. The door lights were built to represent the fallout door lights. A master light fixture was made of cardstock and then cast, as we will need 30 or 40 of them for the whole project. The second level is now installed and holds the actual overseer's office. This insert was made with cardstock and railings from GW's Zone Mortalis sets. No overseer would be caught dead without a big monitor in their office, so we used a 2.5 centimeter 128 by 64 pixel OLED display screen. Here we can see the wiring for it and how it fits into the office's corner. The images on the monitor are driven by the Arduino and were purposefully programmed to look a bit broken. Having never worked with the displays on an Arduino, I was surprised at how simple it was to convert a JPEG image into hex code and then get it into the Arduino sketch. Lastly, the stairs are installed. These were also built from GW's Zone Mortalis sets. Surprisingly, the overseer's desk took a full week to build as it has some very odd shapes and lines to it. In the end, it came out pretty good, and a Fallout Miniatures computer terminal is a nice final touch. With all the individual components installed in the inner shell, we can now insert the inner shell into the outer shell. You can see all the wiring at the back wall and how it will find its way to the Arduino. Being able to remove the inner shell will allow us to paint each component to a higher level than we could otherwise. With all the sub-assemblies installed, we can now attach the wiring, and you can see it temporarily connected to the Arduino. This allows us to properly test everything before going to the next step. Using a bench power supply, we can see the first light up of the room. We're looking for shorts and illumination patterns to ensure the lights are in the proper spots. Passing our functional tests, we can now install the drawer back into its drawer sliders in the actual mountain. This is a real pain in the butt, and fortunately only has to be done once in a while. This will now stay installed until painting and final detailing. We have a lot more bits to install. These will include posters, filing cabinets, desks, garbage bins, wall piping, etc. Most of these items were purchased from Modiphius, the licensed maker of Fallout 28mm miniatures, and will really add to the Fallout shelter vibe. The main color theme will be a pastel blue and yellow scheme, weathered heavily of course. Here we are attaching the room's power to the main power bus of the vault. At this point it is now running on mountain power. Eventually we'll have to do a power study to see how many batteries we'll need. Building drawers that have a ton of wiring, we always have to test the action of the drawers and ensure the wiring does not catch or bind on anything when you slide the drawers in and out. And now we can see the overseer's office fully installed and lit up. It can now be considered construction complete. While a smidge fuzzy on camera, you can see the stuttering images cycling through the monitor in the back corner. Additionally, the computer terminal on the desk gets nicely illuminated by the overhead UV light. Stay tuned for our next room, which will be the agricultural field. Let us know in the comments if you have any suggestions for what to add next series. The hydroponics and agriculture room will be the circled room in our Fallout shelter. There are 14 sub-assemblies for this room, and you can see them all laid out here. The first bit to be installed is the vivariums, which contain some fancy blacklight effects and have been rationalized into the lore of the piece as self-sustaining. The light box was built with some UV light strips and plastic plants that look really good under black lights. Once the vivarium assembly is installed, the floor gets installed that lays out the rest of the floor plan. There is a small catwalk at the back of the room, giving the room a second floor. This gets installed next and fits neatly on top of the vivariums. There are 5 main floor planner boxes. These first 2 are wired in parallel, and the wiring is directed to the sides so it can be buried within the inner shell's walls and lead to the back of the room. Blue painter's tape is used to fasten wiring into their conduits and show these are temporary connections. These will be replaced with masking tape after painting and detailing. You can now clearly see what the oblong shapes on the floor are for. They hold the raised planters in place so they can be removed for maintenance and painting. In the lore of the piece, the agriculture was sufficiently refined so as to require a minimum of soil, hence why they are so narrow. We are continuing to install the planter boxes. Each box has a color rotating LED to represent some electronic status of the planter, as well as overhead lights to increase the rate of photosynthesis that is beyond just the normal ambient light. Because of this, this room will end up being brighter than all the rest. That made sense to me when I thought about it, so I left the lights overly bright. The toughest part of installing these planter boxes is how thin the wiring on the overhead lights is. It's only 30 gauge wire, and that does not tolerate too much torque or stress. I ended up pulling the leads out on multiple occasions, and that resulted in much profanity. Aside from the finickiness of installing the planters, the effects are quite good. The light leaks from the planters will be fixed when we paint. With all the raised planters installed, we can now install the hydroponic shelf on the back wall of the second level. This area will have a ton more bits added during finishing. These will include gardening supplies, hoses, etc., etc. The monitor and climate sensors are the only reason why this room got its own Arduino. All the other lights are simply 5-volt powered LEDs. Interestingly, I used a dollar store strip of LEDs that are all pre-resistored. This saved not only money, but a lot of time when installing these strips. An unforeseen issue, however, with this particular brand of LEDs is that they are really bright and require a lot more power than any other light strip I have used to date. To be specific, this light fixture alone requires almost 700 milliamps of power, where the whole room only draws 1100 milliamps of power. The temperature and humidity sensors are buried inside the greeble I built to hide the electronics. Although slow to react, the climate information displayed on the overhead monitor is real temperature and humidity readings. It takes about 5 minutes for the sensors to stabilize on new values. With all the sub-assemblies installed, you can see how the cable channels on the outside of the inner shell all funnel back to the rear of the room. With everything wired and double checked, we insert the inner shell into the outer shell. During this process, you have to ensure no wires are getting caught up anywhere. The fit is snug enough that if you force it, you will rip out a wiring harness. We can now see the room fully wired and ready for the first power up. Let's hit the go button and see how she looks. At this point during assembly, we're simply making sure everything works as expected and there are no light effects or shadows that we don't want. With our bench testing behind us, the room is now ready for installation into the mountain. This is done by screwing the drawer sliders to the room's outer shell. This process takes quite a bit of time and does not need to be done too often. This drawer will now likely stay in place until painting and detailing. Drop some comments if you wish to see any more detail in these videos or if you have any questions. We'd love to hear from you. The last step in installing the room is to hook it up to mountain power. The right side of the vault is called the eastern wing and powered by switch 4. With everything installed, we power up the mountain to ensure it works as it's supposed to, as well as looking for any light splash patterns that we don't like. Our room is now construction complete and ready for painting and detailing. Next up, the residential hall. Thanks for the time, and I hope we see you again soon. We're working on the 2 rooms identified here with the red circles. We'll start off with the mess hall. There are 11 sub-assemblies and parts. These include the kitchen, storage, and office areas. The largest part will be the dining hall with picnic tables. We're going for a cafeteria-style mess hall. This would include the tray rack in front of the food window. When it comes to detailing, we'll add some food trays and carts. The cold storage in the kitchen area, which are the shelves to the left side of the room, will be frozen somehow. This will include the frosty effect when your freezer door lets in some air. The kitchen area needed a large cooking surface, and I modeled up some deep fryers with a flickering light to make it look like the oil is boiling. The grill itself is modeled after a typical greasy spoon cooking area. Given that this all needs to be painted and detailed, everything is removable just for that reason. It creates some additional complexity in the builds, but there's no way it could be painted properly if everything was installed and glued into place. This was the simplest room we built so far. As such, there's not much mechanical or electrical complexity. With everything installed in the inner shell, we can now see how the wires have been taped down temporarily so that we can test fit it into the outer shell. One of the toughest decisions we had to make was whether or not to leave the furniture movable. In the end, we decided to glue everything down, or they will eventually be glued down. The reason for this was to improve playability. With items that move, they may get lost or get confused as to where they are or which room they're in. There will still be a few items that move and get locked down via magnets, but we did not want to do that with all the accessories. Adding power to the room, we can now see the initial light patterns created. All we're looking for here is anything that's not working or looks odd. You can see the UV lighting in the office that will be used to illuminate a computer terminal on the desk. The mess hall is now ready for installation into the mountain. Next up is our barracks. This main room has 5 sub-assemblies which include 2 sub-rooms, a barracks room and a PMQ, which is a private married quarters. Each of the sub-rooms in the barracks hall were quite complicated to build and include quite a few features. These include showers, toilets, sinks, mirrors, and the PMQ includes a full kitchen. Both of these sub-rooms contain computer equipment illuminated by UV lights. The barracks also has a call closet with a video terminal. The PMQ has a double bed, which is made from cardstock and paper towels. This will paint up very nicely when the time comes and look like real bedding material. The barracks sub-room has bunk beds similarly built. The toughest part was the toilet. We molded a toilet bowl from Sculpey and that did the trick. The showers and sinks include taps and faucets made from fluoro wire. The outer hallway of the barracks room will likely include mailboxes, garbage pails, and an ice chest. These details were picked up from the Fallout Miniatures series by Modifius. The call closet in the barracks subroom is simply a wall of lockers that created a cavity in the room that I needed to rationalize. Voila, a private place for people to make video calls. Lighting was set up for many of the alcove areas, showers, toilets, bunk beds, etc. This creates some very unique shadows that look pretty good. All of the electrical leads are routed to the back of the drawer so they can be attached to the bus bar on the outside of the outer shell. This will then have 9 volts supplied to it from the Mountain's main power supply bus. To ensure a smooth fit between the outer and inner room shells, the wiring channels need to be covered. This is done by painter's tape and masking tape. The blue painter's tape is temporary, and the white masking tape will be used for permanent installation after detailing and painting. With all the wiring taped up, we can now test fit the inner shell to the outer shell. Now that we know it fits, we can attach the electrical leads to the bus bar at the back of the outer shell. Powering up our barracks room, you can see some interesting light and shadow patterns. All we're doing at this point is looking for non-functioning lights and any really odd shadows. Now that both drawers have passed their functional testing, we can add them to the Mountain proper. This is a simple matter of installing each room to its drawer sliders via 4 screws. This process takes a while and fortunately only needs to be done rarely. These rooms will likely not be removed again until the painting and detailing phase. Some viewers may notice that I use a wee piece of foam core. This is used as a spacer measurement tool to ensure the drawers are aligned properly to the room above and below it. Next up for us is to hook the rooms up to Mountain power. Each room has a power lead designed to attach to the main power bus at the back of the Mountain. And now we have our first power up. You can see our 2 new rooms at the bottom of each side and the other rooms previously installed above them.
Today we're focused on the 2 rooms circled in red. Starting with the hospital, let's see how it all fits together. The 14 sub-assemblies that make up the hospital includes walls, doors, and decontamination showers. The floors are all edged so that the walls will click into place and stay put during play. We can see each wall is pre-wired for a variety of functions. These include doorway lights, flashing radiation signs, and an operating room floodlight. All the rooms are done as sub-assemblies so that the painting and detailing can be done later. This allows us to achieve a level of precision that would not be capable otherwise. This particular room does not use an Arduino microcontroller. Instead, the lighting effects are simple enough that we only need to provide 5 volts of power. The exception to this is the flashing radiation warning in one of the decontamination showers. This circuit was built as a standalone circuit made from a couple of resistors and transistors. Installing the walls and lights into an inner shell allows us to mount wiring in such a manner that when installed into the outer shell, there are no wires showing. All the wires are run to the back of the room where the 5 volt bus bar is installed on the outer shell. The decontamination showers are made from lolly sticks heat formed into the shape of an arch. The shower heads are straight pins. With all the sub-assemblies installed and the wiring covered, we can now install the inner shell into the outer shell. With our first power up, we can see large UV areas that will have fluorescent painted computer monitors installed later on. We can also see the flashing radiation alarm. Next up is our reactor room. Diving right into the assembly, we can see 2 main light features of the reactor room. The reactor itself is the large tube highlighted in black-yellow safety stripes. The secondary feature are the fusion core charging stations. Each color on them means something unique. Green is charging in process, red is a fault of some sort, and yellow simply means it's waiting to charge something. The rest of the lighting in the reactor room is either UV lighting for future computer terminals or door lights. There are several Zone Mortalis bits used in the reactor room. These include the railings, stairways, and open conduits that represent maintenance areas of the reactor. The large computer terminals at the front are minis from Scotia Grendel. Our last bit is a Zone Mortalis stairway leading to the reactor platform itself.
Ultimately, all of our wiring will be permanently taped in with masking tape. That won't happen until the detailing and painting is done, however. Until then, we use painter's tape that can be removed later. Even though these are temporary connections, we don't skimp to ensure we can accurately figure out if everything fits into the outer shell. We can now slide the inner shell neatly into the outer shell. Adding 9-volt bench power to the buckboard at the back of the reactor room provides a constant 5-volt of power to everything connected to the bus bar. The reactor and fusion core charging lights are a waterfall style pre-programmed LED, so there is no need for an Arduino in this room. With both rooms passing their functional tests, we can install them into the mountain by screwing them into their drawer sliders. These rooms are now construction complete and await their painting and detailing phase. Once installed, we hook each room up to its mountain power leads. These will now be controlled by the mountain's main power switches. There's enough slack in the wiring harness to ensure the drawer can be opened and closed smoothly. Here is our hospital in all its lit up glory. Similarly, here is our reactor room, glowing brightly. With all but 2 rooms installed in the mountain, we can now see the overall effect of the underground rooms. Our 2 final rooms in our fallout shelter are the supply room and a combo room of a gun range and a bar. The supply room has 11 sub-assemblies, including Mr. Handy himself. The supply room floor was the most challenging piece in the vault. It is an underfloor track that runs a magnet that will move Mr. Handy on the top side. The electronics were pretty straightforward and almost a carbon copy of the elevator electronics. The only difference being it moves horizontally instead of vertically. It has 2 limit switches to control when the traveling magnet shuttle stops. Originally intended to do a circuit of the room, I struggled with getting the magnet shuttle to turn corners. I tried many different variations, but in the end I chose a simple back and forth action. While currently empty, the shelves will hold a myriad of storage containers. These will be added during the painting and detail phase. Each shelf has an underslung colored lights to give us some really neat light patterns. Made of coffee stir sticks and cardstock, they were straightforward to build and only required some finesse to get them installed so they stayed put with their wiring for the lights going through the floor and outer walls of the inner shell. Another challenging part of this room was getting all the track assembly, limit switches, and gearing to fit within the 5mm limit of the foam core floor thickness. To hide the motor assembly and wiring, I added 2 corner walls and will add some iconography to them during detailing and painting. The center forward shelf hides the speaker for Mr. Handy's voice. This worked out nicely. Additionally, the center aft shelf has a UV strip that will shine on Mr. Handy when he walks by and show off some fluorescent highlights such as his engine and eyes. This was a very challenging yet rewarding mechanism to build. There is still an annoying power problem with this room as the lights flicker when Mr. Handy is moving. Annoyingly, it only does this when installed in the mountain and bench testing works fine. The wiring for the supply room seemed to run everywhere. I had to channel the wire runs on the bottom and the sides to ensure nothing crossed over each other. The blue tape will be replaced with a more permanent masking tape after painting and detailing. Taping the wires into place at this stage is still mandatory so that we can install the room and properly test all the functions both on the bench as well as installed in the mountain. Once hooked up to our 9-volt bench power supply, Mr. Handy does his initial power-up move and all the lights work. Now on to the next room. The bar/gun range has 8 sub-assemblies, including a lit dance floor. Everyone who I've shown this room to has immediately asked, is it wise to put a gun range next to a bar? I laugh and say, no, of course not. Such is the comedy we strive for in our builds. The gun range itself was created with some panels from the Zone Mortalis tile sets. These gave me an ability to create an armored illusion in the gun range itself. To avoid building anything that would inhibit gameplay, I decided to put the target tracks in the floor as opposed to overhead rails, like most gun ranges have. This suggests that the targets can move forward and back through that track. I also built the shooter platforms as doors that appear to open and close. The dance floor in the bar was built on a lark, and I really wasn't sure how it would look. In the end, it gives a nice flashy pattern to a room that should be flashy. The floor lighting was made with LED strips, a flasher circuit, and then solidified with UV resin. Once cured, I painted a checkered pattern that creates the light pattern. Fallout veterans will no doubt recognize the jukebox on the dance floor. This hides the capacitors I needed to use for the flasher circuit. The bar itself was made from cardstock and 2 store counters from the Quickie Mart box set from Terrain Crate. You'll see more of Terrain Crate pieces during detailing and painting. The bar stools are merely push pins. They will be painted up to look like 1950s diner stools. It seemed an absolute must to include the Fallout Shelter bar sign light. Now that the wiring is all covered up, we can install the inner shell into the outer shell. Powering up the room on the bench shows off all the UV lights and the flashy dance floor. The UV lights will show off some computer screens and groovy Fallout signage. With functional testing done, we will install the rooms into the mountain. With both rooms installed properly, we're ready for a live test. Next up, we'll hear from Mr. Handy himself.
We have gone 15,330,014 days since an injury. Be smart, be safe!
Mr. Handy has 25 sayings that the Arduino randomly chooses from. I used a Matt Berry voice emulator I found online. Let me know in the comments if I should use this voice or Stephen Russell's voice from the computer game. All the rooms of the vault are now construction complete. Next we will be framing and mountain carving. Our official mascot Titus approves of this message. The parts for this phase include a bunch of timber frames already cut and drilled, as well as some detail bits that we will install once the frame is in place. The gate room gets slid into its mounting rails. Once in place, the main power connectors come up through a hole and gets attached to its leads. I lashed a wee bobbin to the leads so they don't fall into the mountain and get lost. The top of the mountain has had installation tabs put in, and they slide into their matching receptacles on top of the vault itself. This locks it down pretty tightly. The back wall slides nicely into place. With that done, we can install the mounting top lock pins. There are 5 in total. Making this removable ensures we have maintenance access to the gate room and its electronics. Given the bulk of the mountain acts as a gaming table, I accepted the fact that I would need to finish it off very durably. The result are 1x3 inch planks that I cut and drilled to act as edge bumpers, protectors, and edge hiding. The handles on the ends provide a convenient way of moving the mountain. The handles get their strength from being connected to the perimeter planks, and those planks are all anchored to the foam with 8 cm screws. While bulky, the mountain itself serves as a very durable gaming platform that will work well when placed on a table. With the framing installed, we can add some of our larger bits to each of the walls and underground vignettes. The Zone Mortalis pipes from Games Workshop made great conduits for the vault. These will of course be heavily weathered during the detailing phase. I carved out a couple radroach nests that I will populate later. This area will be heavily infested with them due to the broken conduit. The other end of the mountain has our rat mole nest. This too will have critters added later. There is a tunnel that goes up the side and out the front near the gate. Additionally, we're installing piping. These are in cross sections, so I will use some clear resin to fill them with liquids. There will be some heavily weathered vault walls exposed as well. I had a couple interesting geodes given to me, so I thought what a perfect use for them. We will see some close-up shots later on. With everything installed, we do a full systems power-up test. The Fallout Shelter is now coming to full life and is really starting to look like a cohesive piece of art. I'm quite eager to get some Kill Team and Necromunda players to play test this for me. I have some ideas for special rules that I look forward to testing. With everything functionally working, I action the drawers to ensure the cables do not get tangled in the rear. To be honest, at this point, I'm just enjoying the milestone of having everything functionally complete, watching the pretty lights and listening to all the sounds. The piping on the east side will have a radroach nest and some collapsed tunnels. The mole rat tunnel system on the west side will connect to a hole near the gate. The back side features some geodes, rock formations, and some vault wall panels. The gate detail includes some more rock formations and the aforementioned mole rat tunnel entrance. With everything functionally complete, let's review the electronics room by room. The gate room electronics are run by an Arduino, an MP3 player, a servo, a 30 RPM motor, a 3 ohm speaker, limit switches, an H-bridge, and a flasher circuit. The 5 volts is for the rest of the lighting is all provided by the Arduino. The overseer's office has an Arduino running the wall monitor, and the Arduino provides 5 volts for the room lighting. The cafeteria has the simplest electrical setup. There are only a handful of 5 volt lights driven by a 9 volt to 5 volt buckboard. The infirmary has a flasher circuit buried in the back wall for the radiation alarms. Other than that, this room only needs 5 volts for the rest of the lights that's provided from a 9 volt to 5 volt buckboard. The storage room has an Arduino, a 30 RPM motor, MP3 player, 3 ohm speaker, limit switches, an H bridge, and a 9 volt to 5 volt buckboard. This drives Mr. Handy around randomly. There was not a lot of room for the electronics on the back of this drawer. Another Arduino is used in the agriculture room. It measures the thermometer, which is hidden in the air vent, humidity, and displays it on the wall monitor. Additionally, 5 volts is provided from the Arduino to the rest of the lights. The barracks and private quarters room is quite cramped and busy. There are quite a few lights. However, they are all only 5 volt LEDs, so we only needed a 9 volt to 5 volt buckboard for this room. We managed to source some really cool effect LEDs for the reactor room. Because of this, we only needed to provide the 5 volt power from yet another 9 volt to 5 volt buckboard. For the dance floor, a flasher circuit is buried in the dance floor and jukebox. The balance of the lights in the bar and gun range are merely 5 volt LEDs, and they are powered from yet another buckboard. The elevator electronics slide out of the middle section and is run by an Arduino, limit switches, 30 RPM motor, another buckboard, an H bridge, and it is almost a duplicate to the circuitry used by the Mr. Handy room. This is an exciting point as we hit a major milestone. Our piece is now construction complete. Next up, we start the painting and detailing phase, and that's where this really will start to come to life.
The Emperor wishes you a lovely day.